Alright, so today we're actually going to be doing the same kind of thing that we're doing on Friday, but we're doing it without truth tables. Today we're going to analyze arguments, and the way in which we're going to analyze them is with Euler diagrams. That is not Euler, it is Euler, just in case you're wondering. Euler diagrams. And these Euler diagrams are going to have sort of a feel that you had when you did Venn diagrams. But we're using them for a very different purpose, okay? So the first thing I want to talk about in doing this is going back to what the title of the section is, and it says analyzing arguments. And what we're going to analyze them for is to decide whether the arguments are valid or invalid. So imagine in a courtroom, this is what you're talking about. Did they give you a good enough case that their arguments were valid enough to convict or to defend the person that they were working on their counsel for? So valid and invalid arguments. A valid argument occurs when all premises are true then it forces the conclusion to be true. That is a valid argument. Okay? It still may be that you're being sort of, blindsided by somebody when they do this, but if they formed a valid argument, this is the kind of an argument that we're talking about. The other kind is an invalid argument. And an argument that is invalid is not valid. I know that sounds very intuitive, and it is. And it's also called a fallacy. And what Euler diagrams do is that they allow us to have a sort of visual representation of a way to think about arguments. So I know that some of you are probably very visual learners. I'm actually a very visual learner. And so these Euler diagrams, to me, make great visual sense. Okay? And for some of you, you're going to feel that way as well. So these are, like I said, these are much like Venn diagrams. And there are three cases. There are three ways that these can look. So tell me what you remember from Venn diagrams. Does anybody remember anything? They had some circles in them, and that's the part where we're going to see a lot of overlap, if you will, between Venn diagrams and Euler diagrams, is we're going to see circles. So there are three ways that two circles can be drawn. One option is that we have two circles and they intersect, and that's what our Venn diagrams mostly look like, right? We had two overlapping circles. You saw one other case commonly, not maybe commonly, but you did see it, and that was where you had one circle inside of another circle. Do you remember that one? You had one of those on your test, right? Subsets is what we talked about those being. And then a third option is that you have two circles that do not overlap. Now what you do not see, and for very good reason, is any rectangles around these. There aren't rectangles drawn around Euler diagrams, okay? Now, there's three different cases up here. The first case, where we have the overlapping circles, well, I'm going to give you an example of each of them. So an example of this case would be something like this. If I said some people are, that's our mothers. These two overlapping circles would be a representation visually of what that's talking about. One circle would be all the people, and one circle would be all mothers. So the people in the overlap are the mothers who are people. What other mothers do you know? You guys are looking at me like I'm crazy. People were the only ones who have children. People are the only ones who have babies. Really? Dogs. Sure. Are there mother dogs? Yes, there are. Are there mother hamsters? Yes, there are. Are there mother alligators? Yeah. Okay, we got them all at the zoo. They got lots of babies, right? Everything has babies. So this is our picture, right? This circle's people. The overlap in the middle are, moms that are people. And this overlap would be animals or other creatures or whatever that are our mothers. Over here, what would be over here in our people circle? Well, all the men would be over there for sure, right? Yes. And then everyone else who doesn't have children who are women would be over here too. So my kids would be over here because they don't have children of them of their own yet, right? I think all of you would be in that circle on the side, wouldn't you? I think we decided that last time. So, so this is our picture, okay? So the key word here is some. When you see the word some, you get overlapping circles, okay? That's what happens. Let's do the next one. This one, as an example, we can do all dogs are animals. Okay, so the circle in the middle, that little circle, that's dogs. My outer circle is animals. Okay? Dogs are inside of a broader category called animals. I couldn't switch where I've written these because not all animals are dogs, right? I've got 2 of them in my house that are not. I have 2 cats. That wouldn't work. The key word here that helps you know that this is the diagram to draw is the word all. When you see the word all, you got one circle going on inside of another circle. Okay? Any idea what the last one might be? None or no, yes. So here's an example of this one. We could have no hamsters. Pretend like that finished. Hamsters live at my house. We don't have rodents. We have scorpions, but no rodents. We don't want them. You can have the scorpions if you'd like to come. You can take them all away. My husband keeps trying to get rid of them. All right, but we don't have any hamsters. So we've got these 2 circles. One circle is obviously hamsters, right? And it's not crossing over into the other circle because the other circle, what would it be? Yeah, well, the things that live at my house, right? So we would have over here, I don't have a way of my screen's too small, but we have the idea here that these are things. Okay, that didn't look good. Let's try again. Things at my house. So exercise on how small can I write. And the key word is no. No, the key word is not hamster. The key word is no. All right, so every diagram we draw is going to be one of these 3 types. We're going to have overlapping circles, enclosed or containing circles one around another, or we're going to have circles that are disjoint, unconnected at all. And to decide whether an argument is valid or invalid, we're going to draw our picture, and we're going to infer from our picture what the situation is. So here is an example. It says decide whether each argument is valid or invalid. The first statement is all politicians lie, cheat, and steal. So our first goal is to draw a circle, or 2 circles rather, that represent the first statement. The next 2 statements have nothing to do with what I'm starting with. I'm starting with statement number 1, the very first line. What kind of circles would I draw for that first statement? Circle inside a circle, right? Because of the word all. And then we have to decide what those circles are labeled. Can somebody tell me what one of the circles is? Politicians. And where are they? They're the inside circle, right? This inside circle is politicians. So what does that make the outside circle? Yeah, these are people who do that, right? people who lie, cheat, and steal. How appropriate is this that we're in an election year and we're doing this example? All right, very appropriate. Okay, so that is my first statement. This is the diagram that first statement reads. The second statement is not two circles. It's a statement that talks about where a specific person would be in this diagram. That man lies, cheats, and steals. And so we're going to let that man be X. We should have given him a name, but I didn't. That man. That man, where could that man be in terms of this picture? Anywhere inside the larger circle, which means he could be here or here, right, Britton? Yeah. Exactly. He could be in either, well, there you go. I drew it. All right, so he could be in one of those two spots, yeah? So now we look at this line. This line right here at the bottom means therefore, and what we're wanting to decide is if what comes after the therefore actually logically follows. This, what we're trying to decide if it naturally follows or logically follows, is that man is a politician. Do you know by this argument that the man is a politician? No. Because the X's that I drew, one of them was in the politician circle, but one of them wasn't. Correct? So that man could be something else. Maybe he's a lawyer. Some of them lie, cheat, and steal. Maybe he's a school administrator. Maybe he's a math teacher. He could be. That's true. Yes. He could be anything, right? He could be anything in that outer circle that does not include politicians. So what we have to decide then based on this is my work that I'm showing. My answer is whether it's valid or invalid, and it is invalid. This is an invalid argument. So if a lawyer presented this to you in a court case, you would have to sit there and say, now wait a minute, that doesn't work. It doesn't follow like that, right? So let's take a look at another one. Some nurses wear blue uniforms. Again, we're just stop with the first sentence because that's what we have to draw the picture for. Some nurses wear blue uniforms. What will my picture look like? Overlapping circles, you betcha. What are my circles that overlap? What are they called? One is nurses, and the other one would be people who wear blue uniforms. You must label your circles. Otherwise, it doesn't make any sense to continue the problem. Now we've got D. Boyle, so we're going to let her be X. Let me change the color to yellow. I think it'll show up better. All right, there's X is D. Boyle. D. Boyle is a nurse. So where could I put the X in this diagram? Okay, so it could be out here, right? Or it could be in between, either spot, yeah? We have two different spots where it could be. And then we have to decide if it logically follows. D. Boyle wears blue uniform. Not necessarily. She could be the X that's in the overlap, in which case she does wear a blue uniform, right? But does she have to be in the overlap? No. She could be in the outer part where we put the other X. There's two different locations, and not both of those locations are blue uniforms. So is the argument valid? No. It is an invalid argument. Based on the information that we have been given, we do not know if D wears a blue uniform. Are you following? Pictures make sense? Okay. All disc jockeys play music. What will that look like?
A circle with gears.
A circle. Whoa, that didn't look like a circle. Let's try again. A circle inside of another circle. Where are my disc jockeys? Oh, I hear both. Which one? They're in the little circle. And the reason they're in the little circle is because it says the disc jockeys play the music, right? All of the disc jockeys do something else. Okay, they may do other things too, but they all play music according to this description. So disc jockeys goes in the middle. What goes in the outer circle?
People who put-
People who play music. Are you with me? Everybody okay? What would I do next? What's my next step? To decide what X is. What is X going to be according to my second sentence? This is Flash Phelps. Where's Flash Phelps going to be? Inside the little circle. Can he be anywhere else, Jessica? No, he can't. Because it says he's a disc jockey. If you put that X outside of the disc jockey circle, then he's not a disc jockey. So he can't go in the outer circle. He can't go on the outside of both circles. He can't go anywhere else except for this one location. There's only one X in this diagram. And we have to make the decision. Is Flash Phelps for sure someone who plays music according to this diagram? Yes. Why? Yes. And so Flash Phelps is also by default in the plays music circle, isn't he? He is. He's in the plays music circle. So is the argument valid or invalid? This one is valid. All right, so we're going to construct a valid argument based on a picture. And I should have put the picture in ahead of time. I didn't, so I'm going to put it in now. I'm going to have a big circle and a little circle inside of it. My big circle is going to be called pet lovers. My little circle is going to be called cat lovers. I'm going to have an X inside of the cat lovers circle. And on the side I'm going to say that X represents Jessica Long. And that's what yours says, right? All of that's on yours. All right, good. So we're going to create a, I want to do that. I want to do, this there. I'll try that. Okay. We're going to create a argument I need more space, so that'll work. We're going to create an argument for this. And so the argument, remember, had had three pieces to it when I looked at the previous three examples. I have two statements, and then I have a line, and then I have an argument's conclusion down here at the bottom. Everybody with me? Okay, so what's the first line of my argument going to be?
All cat lovers love pets.
All right, that sounds good. All cat lovers love pets. Or you could say all cat lovers are pet lovers. That'd work too, right? Now what?
Jessica Long loves cats.
Jessica Long loves cats. And then I draw a line, yeah? And what is the conclusion that would be formed based on this?
Jessica Long is a pet lover.
Jessica Long is a pet lover. What do you think? Is that all right? Okay, we're going to do one more example. What do you notice that's different about this one?
There's 4 lines.
There are 4 lines. There's 3 above that equals bar, if you will, or whatever the therefore bar. And that makes the diagram do what do you think?
Add a circle.
It's going to add a circle. That's exactly right. So we're going to end up with 3 circles. At least that's one way of doing it inside of my picture. Okay? So let's read what these arguments say. We're going to decide if the argument's valid or invalid. It says all people who drive contribute to air pollution. It says all people who contribute to air pollution make life a little worse. It says some people who live in a suburb make life a little worse. And then it says some people who live in a suburb drive. Okay, are you with me? Okay, we're not deciding if the statement's true or false. Okay, we're deciding whether the argument is valid, and that is a very different statement. Okay, so we're starting with the first line, just like in the other ones. All people who drive contribute to air pollution. What will that look like? Circle inside a circle. We'll get there in a minute. All right, so I think the first statement is talking about people who drive. So where are the drivers? The drivers are in the middle, because that came at first in our argument. So here are our drivers. Okay, people who drive. You could say people who drive, that'd be fine. And what is the outside circle? Yes, so this is people contributing, or you could even say things contributing to air pollution, right? There are things besides people that contribute to air pollution. This is my first diagram, but there's more going on. My second statement says all people who contribute to air pollution make life a little worse. So I'm not drawing another diagram completely. I need to add to the diagram I have. And how will I do that? A bigger circle around what I already have, right? I know it looks more like an oval. I'm okay with that. What is that outer circular shape going to be? People who make life a little worse. Okay, so you don't have to agree with anything that was said in those statements. That's not the point. The point's to draw the picture, which we did. Now, we have one more statement here. It says, some people who live in a suburb make life a little worse. And I don't want you to get confused by the word some. So the word some here, when we're drawing the first pictures, could mean we overlap circles, right? That's true. But that last line in there generally is easiest to be thought of by doing the X. Okay? So we're going to let X represent some people. All right? So X is my some people. Where can these some people be according to the third sentence? Anywhere inside the circles, right? So they could be here, or here, or here. We don't know, but they're somewhere in there. They're one of those X's, or could be multiple places of those X's or whatever. Okay, so that's my diagram. What I'm trying to decide is if some people who live in a suburb drive by default. Do they have to? Does that have to be the case? Do some people have to drive that live in a suburb? We're a class divided. The X's are in different spots, but do they have to be in all those spots? You have to remember why we put the X's there. We put the X's there because they could be there. Do they have to be there? No, they don't have to be in all those spots. Could they? Yes. So if it said some people could drive, well, it could. They could. But do they have to? No. So this argument is invalid.
Can you go back a second?
On the other slide?
Yeah.
Yeah. Okay. So I wasn't real clear when I wrote my some people. These are some people living in a suburb, if you want me to be clear.
Why do we put X's in all of them?
The X's represent the places that the some people could be. My statement over here said that these some people make life a little worse. And my outer circle, the big circle here, is the people who make life worse. Which means that the X could be the people in the driver's circle, the X could go in the pollution circle, or the X could go in the making life a little worse circle. So all of these some people Could be people who murder, but they don't do anything about pollution, right? And they live in New York, I don't know, they live somewhere else. They don't live in the suburb. Okay, so the some people that I'm referring to may have nothing to do with driving, they may have nothing to do with these descriptions, but they fit into the one category we're talking about by making life a little worse. They just make life a little worse some other way. Does that make sense? Okay.